When we do calculations in physics, when we combine two quantities, whether it's adding two lengths together or calculating the density of a material by dividing its mass by its volume, we need to make sure that our final answer, the number that we give, has the right number of significant figures, that it reflects how well we know that number given what we started with. So here are two rules that we use to round when we're doing calculations. The first is for adding or subtracting two quantities. And in that case, we round the answer to the smallest number of decimal places. So an example of this is, just say we were adding 13.5 centimetres to 1.23 centimetres. Well, the answer that you might calculate first off would be 14.73 centimetres. But if we look back to the original numbers, we see that this first number, the 13.5, we only know as well as that first decimal place. So the question is, if we add those two numbers together, how can we know the final answer to the second decimal place if we only knew one of the original numbers to only one decimal place? So this is where we apply this rule, that instead of being 14.73, we round it to the same number of decimal places as the one that had fewer of them to start with. So it would be 14.7 centimetres. And another example, just say we had 835, let's say, newtons, units of force. Whoops, let's make it a subtraction this time. Minus 1.3 newtons. Maybe someone's pulling really hard one direction and someone's pulling a very small amount in the other direction. So 835 minus 1.3 would give us 833.7 newtons. But again, we only know this number here to the units place, which is less precise than this one over here, which we know to the tenth of a unit place. So when we subtract the 1.3 from the 835, we know we can only know this final answer to this decimal place here, or this unit here. And so what we'd need to do is round that up to 834 newtons. Our second rule is, when multiplying or dividing quantities, we round to the smallest number of significant figures. So in this example, we're going to divide, say, 2.0 kilograms mass divided by 3.62 cubic meters. This number here, the 2, has 2 significant figures, whereas this has 3 significant figures. So we need to round the final answer to 2 significant figures, which gives us, well, if we did it without rounding, it would be 0.55248, and that would be kilograms per cubic metre. But of course, we can't have that many significant figures if we only knew the first one to 2 significant figures. So what we're going to do is cross out those extra 3 there, and our final answer is 0.55. And our final example, we're going to multiply 2 things together. So let's have 33 meters multiplied by 0.002 meters to find the area of some object. And if we did that without doing any appropriate rounding, it would be 0.066 square meters. But of course this 0.002 only has one significant figure, whereas the 33 has 2, so we need to round our final answer to 0.07. And so by doing that rounding, we make sure that our final answer is not too precise or inappropriately rounded, given the original quantities that we needed to do that calculation.